Good day to you all. I am C.S. Srinivasarao, Associate Professor, Department of Computer Science, SVKP and Dr. K.S. Raju Arts and Science College, Penigonda. Welcome back to Kruskal's algorithm. This algorithm is used to construct the minimal spanning tree. So this is the greedy algorithm, greedy method. Choosing in this Kruskal's algorithm how to find the minimal spanning tree. Step one is choosing any edge with smallest weight. Choose any edge with smallest weight and consider it. Consider it into spanning tree. Successfully add edges with minimum weight that do not form a simple circuit. With those edges already been chosen. So from increasing order, this is like increasing order. Just you consider the smallest weight edge and frame from there onwards. Successfully we add the smallest small weights from the remaining list of edges, and without any simple circuit is formed. Like that the process will continue until n-1 edges and you reach all vertices. Now you go for the one numerical example. This is the same algorithm which is explained in PRIMS. For this you construct the spanning tree. So here this is the one graph with number of edges or number of weights, or the number of vertices are 12 vertices and with different weights, right? So in this Kruskal's algorithm, just you find the edges with the minimum weight. So one is the minimal weight is, one is BF, second one is CD, third one is KL. These are the three edges. Among these three, choose one vertex. This is CD is the one vertex. So CD is the one edge. CD is the one edge with weight is 1. And what is the next minimum edge? One is the maybe BF and KL. You consider any one. So if you consider the KL, this is the KL. Just verify this is an edge and second edge is this one. Is there any circuit? There is no circuit with these two edges. With CD and KL, there is no circuit. Now you consider it. Consider this edge also. That is the KL with weight 1. And third is this one, BF. This is. So totally 3 edges. One is CD, second one is KL, and third one is BF. So if you consider these 3, there is no circuit. Hence, you consider all these 3 with weight is 1, 1, 1. Right. After that, what are the remaining edges with weights? 2 and remaining 2. This is 2. This is 2. Only 2 with weight 2. 1, 2, 3 edges. 3 edges are there. Now you consider the CG. CG is this one. This is CG. This is CG is this one. CG is this one. You consider this one. There is no again simple circuit because you already consider this one. This one. If you consider this one, there is no circuit. Now you consider this one, CG. And AB, if you consider this one, is there any circuit? No. So you consider this also because there is no circuit. And FJ, this is, and the next one is AB. After that FJ. FJ is this one. You consider this one also, FJ. That means what are the edges you consider? 1, 2, 3, 4, 5 and 6. This, right? Here this one and this one and this one. There is no simple circuit up to the here. And the next weight is 3. 3 is BC, it has 3, AE 3, GH 3, HL 3, JK 3, IJ 3, FG is 3, GH is 3, right? For example, you consider what is the next? BC. If you consider this BC, is there any circuit? So you already chosen. CD is chosen, this one is chosen, this one is chosen, this one is chosen. If you consider this, there is no circuit. If you consider this BC, there is no circuit. And you also consider this one, again it forms the circuit. So that's why you don't consider this FG. You don't consider this FG. If you consider the BC and AE, JK and IJ, GH. You consider all this. If you consider this GH, there is no circuit. Here because this is not considered. You consider this GH. After BC, JK is there. After BC, JK is there. Where is JK? JK is there. So because there is no circuit, and GH is there, there is no circuit. Don't consider this FG. If you consider this FG, it forms a circuit. It forms a circuit because you already chosen CD and CG, CG, BF, BC. If you consider the FG, that forms a circuit. Don't consider this FG. GH, you consider GH because DH is not considered. So here LK is considered. So HL is not considered yet, and GK is also not considered yet. So once you consider GH and IJ, this IJ is considered. So IJ is considered, that is 3, and AE is considered. So hence you visited all vertices without any loop. That means this is considered, this is considered, this is considered, and HL is not considered. HL is not considered. So this is considered, and CD, CG, GH, one GH, and CB, BA, and FJ, and JK, FJ and JK, IJ, AE, KL, JK, KL. See that? CD, GH, this one you consider, this one is considered, 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 this one is considered. All vertices are covered without any loops. So hence these are the edges. You consider it according to the Kruskal's algorithm. Minimum weight is 24. This is the minimal spanning tree according to the Kruskal's algorithm. What is in Kruskal's algorithm? Just you find what are the minimum weight edges and check is there any simple circuit formed. So initially with weight 1 CD, BF, LK. If you consider all these 3 edges without any circuit, and you consider you add the circuit, add the edges with the next minimal weight. Next minimal weight is 2. You can consider this CG, you can consider this AB, you can consider this FJ because there is no circuit, and you find 3. This one, this one, this one, this one, this one, and this one. 1, 2, 3, 4, 5, 6, 7. There are 7 edges with weight 3. And if you consider this one, there is no loop. If you consider this one, this is already considered, this is already considered, this is already considered. If you consider this one, that forms a loop. So don't consider it. And if you consider this one, yes, you consider it. You consider this one. You already consider this one, right? You already consider this one. There is no form. And here is HL. If you consider this HL, here GH is there. HL is also already considered. You already reached H and L also reached. Don't consider this additional edge, right? So one is this one, 1 with 1, 3, with 2, 3, and with 3, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. With 2, 3, with 1, 3. 3 plus 3, 6 plus 5, 11. 11 edges. Totally 12 vertices, 11 edges is enough. So don't consider this H and L, HL edge. So this is the minimal weight is 24. See the Kruskal's algorithm. Procedure Kruskal's. This is the G is the connected undirected graph. This is the input with vertices N. Initially the T is empty graph. In the previous Kruskal's Prim's algorithm, you take the first minimal edge. So that's why the for loop is for loop is running from 1 to n minus 2, because total number of edges are n minus 1 only. You already one edge is considered, the n minus 2 times will repeat this particular for loop in Prim's algorithm. But whereas in Kruskal's algorithm, initially the t is empty, so hence the for loop will repeat from 1 to n minus 1 times. All n minus 1 edges are considered within this for loop only. So for loop begins. Consider the E edge. E is an edge. This is an edge, any edge in G, any edge that is not incident or adjacent. Any edge with the smallest weight that does not. The condition is that does not form a simple circuit when added to T. If you consider the particular edge, verify whether the circuit is formed or not. With that particular edge, if there is no circuit with minimum smallest weight, you consider it. You add it to the spanning tree. Like that, you repeat all the minimal value edges until there are n minus 1 edges. So the loop will continue up to n minus 1 edges. Right? This is the Kruskal's algorithm. So you will get this one. So the diagram is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. These are the edges corresponding to the minimal spanning tree. This is the minimal spanning tree according to the Kruskal's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. These are the edges you consider. Thank you. Thank you, Anand.